Good evening to our lecturer, Data Stock lecturer, Atira. We are from DDT 3D S4, and to explain about our mini project, we are in a group of 3: me, myself, Kirsha, Tulasi, and Vijayashri, and I'm gonna be explaining about situation 1. Situation 1: Data Struct course have 8 classes. Each class can hold maximum 30 students only. Assuming Inche Hazainu want to store final examination marks of his class, the way Inche Zainu stores the data is random and not necessary to sort from the highest to the lowest. So the data type that we use here is stack. It's because we can create a stack for each class to store the final examination marks for the students. Each stack will represent a class, and we will push the marks onto the respective stacks. Since the order of storing the marks is not sorted, using a stack is appropriate as it follows the last in first out principle by setting every class max capacity of 30. This will be the illustration of the stack. That's all from me. Thank you.
Hi, my name is Vijayashri and I will be explaining about situation 2. Assume that you are in your office and there is a network of 5 computers. You have connected all these computers to a single printer. Suppose an employee wants to print his documents and send a comment to the printer through his computer. The printer receives the comments and starts printing the documents. At the same time, another employee sends comments to the printer. So the data type that we use for this situation is queue. The process is when an employee sends a printing command from their computer, the command is added to the end of the queue. The printer processes the comments sequentially starting from the front of the queue. For example, the first comment that was added. As soon as the printer finishes processing a comment, it is removed from the front of the queue, and the next comment in the line, if any, becomes the next one of the process. So the first computer will be at the front, the following computers that added at the back will be known as rare. So the explanation is a queue is a linear data structure that follows the first in first out FIFO principle. It means that the first element added to the queue will be the first one to be removed. In this context, the printer can be represented as a single resource, and the queue will help manage the printing requests from different computers in an organized and fair manner.
Hi guys, my name is Tulasi Vijayaraj. Okay, let's talk about situation 3. An operating system may use this type of data structure for directories, files and folder in its file management system. The data type is tree. Explanation: an operating system uses a tree-like structure to organize files and folders, with the root directory as the topmost nodes. The hierarchical arrangement of directories and files form a file system tree stemming from the root directory. Folders and files are organized in the tree-like manner, with a root directly serving as the main starting point. Thank you.
Now I will be explaining about situation 4. Google Chrome is used to surf the internet. Backward button can be used by a user to go to the previous page when it's clicked. So the data type that we use is stack. For example, after we click to a new tab and then the following tabs, so to go to the back tab, so we will go to the back tab and then the previous tab will be removed from the stack. So the first one, we have 4 tabs, and then that tab C is the current page. Then after we click the back button, so it will go to the previous tab. So until at the last, the new tab will be the current page. That means the first tab that we click will be the current page. The rest will be removed. So the explanation is, for the situation described, the correct data structure to manage the browsing history and enable the backward button functionality in Google Chrome is a stack. The last element added to the stack is the first one to be removed from the stack, which is a linear data structure that follows to the last in first out LIFO principle. When you browse the internet, each new website you view rises to the top of the stacks as you move from one web page to another. The top element in the stack, the most recently seen page, gets deleted when you click the backward button, essentially returning you to the previous page. Thank you.